Okay, so the main thing I want to talk about in this lesson is the standard normal random variable. But first, I just want to talk about standardizing random variables in general. We can standardize any random variable, and all that means is transform it into something that has mean 0 and standard deviation of 1, variance of 1. Okay, and you guys actually did this in a homework problem, or you tried to do it, where you looked at this linear transformation. Okay, so you started with random variable x. Okay, so x has mean, mu, and standard deviation sigma. And I'm not saying it's normal, it could be anything. And let's look at z, which is a function of that random variable. Let's let z equal x minus mu over sigma. Okay, and so here's one of these situations that we find ourselves in sometimes where we are working with the mean and the standard deviation, and they are those things. They're the moments of the random variable, but they're also just numbers, okay? And so in thinking about this transformation, let's first not focus on the fact that mu is the expected value and this sigma is the standard deviation. Mu is just a number and sigma is just a number. And so this is a linear transformation. If you want to think about it, it's like ax plus b, where a is just 1 over sigma and b is negative mu over sigma, right? That's all we're doing here, okay? And then thinking about what that means, then the expected value of z is going to be expected value of x minus mu over sigma. Okay, so dividing the expected value of x by sigma and subtracting off this mu minus sigma. Fine, that's just the expected value of a linear transformation is a linear transformation of the expected value. That's the step that required us to think about mu and sigma as numbers. Now we can remind ourselves of what number mu really is. Okay, mu is the same number, as the expected value of x. Okay, so this is just mu minus mu over sigma. It doesn't matter what sigma squared is, it's 0. Okay. And similarly, we know the variance of z is going to be it's the variance of ax squared plus b is the variance of ax plus b is a squared times the variance of x. Okay. So here our a term is 1 over sigma squared. It's 1 over sigma. Okay, so it is sorry, trying to get my pen to come back here. 1 over sigma squared var x. Okay. But what is sigma squared? Oh, it's var x. Or what is var x? We can do the substitution either way. Sigma squared over sigma squared equals 1. It's simple steps. I always sort of feel like there's a rabbit going into a hat here. But, and I'm not sure if what I just wrote is visible on the screen or not. I'm going to stop the share for a minute and reshare to see if I can avoid this problem that we have sometimes where I'm writing like crazy on the board and you guys can't see it. So bear with me on this. And now it looks like you can see the whole thing. Not bad for me to perhaps go through this, the same process again. So thinking about standardizing the random variable just means subtracting off its mean value first, and then dividing that difference by the standard deviation. There was no stipulation in any of this that the random variable was normal. So you can standardize any random variable to turn it in to something that has mean 0 and standard deviation of 1. Sometimes you do this outside of the normal distribution. For example, when I have a class where I've got a bunch of TAs and there's concerns that maybe they're not grading things the same way, if you standardize all their grade distributions, so subtract off the mean grade for each TA and then divide the difference by that TA's standard deviation, everybody's distribution will now have a mean grade of 0 and a standard deviation of 1. And if you want to retransform that to something else, you can, or you can just work with the standardized values. Okay. I actually think I'm gonna, since we have a little issue with the screen there, I'm gonna stop this video now because the standardization process is kind of a point by itself. And I'll add a second lesson where we apply this to, I guess it'll be a fifth lesson for this, this unit, a next lesson where we apply this process to normal random variables. So I'll see you in that video in just a second.